question about a block of mass m sliding down at constant speed. Bit equation-y this one, so take a look and see what you think. Okay, so as I've alluded to in the start of the video, this is quite a sort of formula-heavy question, which I think students get a bit afraid of. But actually, when you look at it, it's kind of okay. You just need to work through the steps, do your working, write it down, and follow your process, and you should be able to come to an answer which makes sense. Let's have a look. We're told that it's traveling at constant speed, and therefore we are in dynamic equilibrium. And what that means is that the forces acting up and down the slope must be balanced. Now we know that the force of friction acts up the slope and the component of weight acts down the slope. And that means that mg sine theta, which is the component acting down the slope, must be equal to the coefficient of friction times the normal force. Now, if we just do a little bit of rearranging, we can say, firstly, mg sine theta is equal to mu d times n, and therefore sine theta is equal to mu d over mg. Theta, therefore, is equal to the inverse sine of the product of the coefficient of friction by the normal force divided by mg. So that's our answer D. Now, like I say, this is one which just takes a bit of equation manipulation, but it really is just using the ideas of force balance in a different way. So really, when the people who made this question are really testing your understanding of what dynamic equilibrium is, how that applies to these ramps, and then how you can rearrange equations. Lots of skills there, but one that's a really good one to practice. Hope the explanation helps.